Hello and welcome to our monthly virtual lecture. As a reminder, this lecture is being recorded and will be available on our YouTube channel in the coming days. My name is Christopher Davis, and I'm pleased to introduce our speaker today, Carla Gonzalez. She will be showing us what is new in Geoscience Analyst version 3.4. This is a new release of Geoscience Analyst, and I have been told that it should be any day now when it's released. Carla will be highlighting improvements to our raster importer, contouring 2D grid properties, importing seg-y 2D files, transferring data between objects, and running Python scripts from a drop-down menu. If you have any questions during the presentation, feel free to type them in the Q&A or raise your hand. Please be aware that Carla may wait till the end to answer the question. Carla, take it away.
All right, thank you, Chris. And hi, everyone. Thanks for joining us today. It's my pleasure to show you some of the new features in Geoscience Analyst's latest version 3.4. And so today I'm going to get started with some of those raster imports that Chris was talking about. So if I go to the File menu, Import Raster, you'll see now we have this raster menu where we can now import Geotiff, ER mapper grids, and surfer grids. So I'll open this, I'll go to my data, and yeah, so you can see here you have the tiff.ers and the .grd, and I'm gonna be importing a DEM Geotiff as an example. So click open. Then I had to set it a default elevation. I'll just leave it at 0. And here I have this Geotiff, which before we did support Geotiff, but it would import as an image. Now you'll note that this is importing as an actual 2D grid. And what that means is that you can now paint by the bands of that Geotiff, which we support single band and multiband. You can query the values in your 2D grid. You can change the color table. You have all the default visual parameters for your 2D grids, like deforming by data. So you have all your usual 2D grid functionality here for your Geotiff import. Great, so now something I'll do is with Geoscience Analyst Pro, I'm going to be creating a surface from data. And I'm going to use that band data. That is my actual elevation values in that Geotiff. And I'm going to call it DEM surf. Okay. Great. So here I've created an actual like triangulated surface that is in the right location. So I've essentially created my topography surface from that Geotiff that we imported. And we're going to be using this later. So I'll just show another raster import. Here I have an ER mapper grid. I have some gravity data.ers. So I'll drag and drop that in. I'll again set it at 0 meters elevation. And it's very similar to the Geotiff import. It's a 2D grid. You can look at its cells, paint by the milligauss, and just the same things, the usual 2D grid functionality that we have there. Now we do have a new 2D grid visual parameter, and that is that you can now show contours on your data. So here I'm showing contours for my milligauss, and you can see that here in 3D. Now the anchor is where those contours start, and it's by default the minimum of your data. You can change that if you like. You can change the interval, or let's say I want only 10 contours. I can change that and then suggest contours, and it's going to give me the best interval to fit that. And I'll just actually bring it back to how it was. Yeah, like that. You can change the color of the contours. And this is all just a part of the visual parameter of the free functionality of Geoscience Analyst. Now, the part that is part of Pro is this create curve. So if I create a curve right here, you'll see we have a new object in our objects tree. It's called contours for a property, band milligauss, gravity data. So this is a curve object that we created, and you'll see it's those contours with still that milligauss data painted on it. Now I'll just show an example of something you can do with these contours, and that's that we're going to drape them onto our topography surface. So I'll right click on my contours, drape on, and select my topography surface. Okay, great. Now I'll just put some vertical exaggeration to see this a little bit better. And so now we're kind of looking at our gravity data here with those contours draped onto our topography. So you can kind of analyze both at the same time. Maybe you're seeing here there's a high grav anomaly, high grav values at least, where we have a high topography and vice versa. So maybe that can give you some information as to what rock units are in that area. Now, something else you can do with the contours is that, and it's not just for contours, but it's for any curves, is that you can now export those with to Geosoft database, GDB, and to S3 shapefile.shp. So now we have these two new exports for our curve objects. Okay, I'll just bring this back like that. Okay, so now I'll move away a little bit from the raster imports and I'll go on to the 2D seg-y. So now if you have a seismic line in seg-y format, you can just import that into Geoscience ANALYST. It is going to be guessing whether it's a 2D section or 3D model. In this case, it's true, that's a 2D section. You can set the different parameters. It's going to give you a summary of the dimensions. And once you're ready, you can click OK. Okay, and here is our 2D seg-y import. That is the seismic line. And you'll notice this is an entirely new object that we created for this. It's called a draped model, and it represents sections that can be draped both laterally and vertically. Yeah, so here we're visualizing amplitude. I'll just change that color table, make the flag, and I'll also change the min and max of my linear mapping function just to see the data a little bit better. That's looking okay. Great. So then for visual parameters for this object type, you've got color, transparency. You can only show you can also show the grid, which you can see here. These are all the different cells. There's 2.2 million cells in this one draped model, and the cells don't have to be regular space. They can also be irregular space. Okay. But now one other thing that you can do with your seismic line is that you can drape it on your topography surface. Now you'll see here this is came in at 0. I specified it to come out at 0 meters in my import, but now I want to put it over here. So I'm going to right click and drape on, and again select my topography surface. Okay, so now it should be at the right elevation. And now I can maybe do some interpretation on my seismic lines, create curves, maybe create some simple surfaces out of that. Okay, so that was the 2D seg-y import. Now I'll move on to this Geoscience ANALYST Pro tool, which is that you can now transfer data between objects. So let's say that I have a geology model. I have one right here. That's my geology model that we're looking at here. And let's say I want to transfer this geology data from my model onto my seismic line. So I can choose my model with this geology data. You can choose the seismic line. And then I'm just going to put a search radius of, let's say, like 50 meters. And what that means is that if there's a cell that is more than 50 meters away from our geology model. It's going to say you're too far for me to transfer that value. You're going to end up being a no data value. And once I'm ready, I can hit OK. Data successfully transferred. That's good. So now I can display that flim-flam geology on my draped model object like that. And I can go between one and then back to the other. Now, I will do another example of transferring data between objects, because there's a lot of different applications for it. But let's say that I have been sent the results of a magnetic inversion by one of the geophysicists on our team, and I want to visualize this in the same block model as my geology model. So what I can do in this case is, again, go and transfer that data. So I'll select my source as my magnetic inversion and the destination as my model. And I'll click OK. All right, the data has been transferred. I can come over here and see that I have a new column on my geology model, which is that result of my magnetic inversion. Here you have it. So again, I can flip back and forth between my geology and that magnetics. Now, something else that I can do at this point is that I can turn on property blending on my block model. So what this means is that I'm visualizing kind of two properties at the same time. I'm visualizing my magnetics and I'm blending it with my geology, so that if I go to 0, you're looking at just magnetics. If I go to 100, it's just geology. And if I go somewhere in between, it is a mix, or it is a blend of these two data. And so now I can see if maybe I have magnetic anomalies around certain rock units, or maybe on the faults. I can move this, and you can see that where if they've modeled the ore body in my geology model is also where I'm seeing a magnetic anomaly in my magnetics inversion. So this is just allowing you to kind of combine those two data for your analysis. Great, and just to finish off, I'm gonna be going into the last thing on our agenda, which is about Geoscience ANALYST Pro and its Python API. So you can now create your own custom expansion of Geoscience ANALYST with what we call a UI.json, which is a text file that describes the user interface. And we're going to be getting into all the details of that later, but first I'll just demo what it looks like when it's all set up. So for Geoscience ANALYST Pro users, you'll now see a Python menu here in your menu toolbar. And here you'll see a list of your various Python scripts. So I've created a Python script to compute distance from one object to another. And yeah, that's fine. So here I want to compute distance from this block model to my faults. Maybe my faults are conduits for hydrothermal fluids that are associated with mineralization. I want to see where I'm closest to them and where I'm farthest. Okay, so the source here will be the faults, destination, the block model. And this is going to launch a process to run my Python module, which is distance_comp, which is a Python script that I have in my computer. So this is loading the objects in the data. It's running that Python script on the background. Then it's going to write the results back to Geoscience ANALYST, where we're going to be able to visualize it in 3D. And it just takes a couple seconds for it to run and write back. And there you go. Okay, so now in this model, I have this new data column called distance to faults. So you'll see wherever it's blue, I am close to a fault, and where it's red, I'm farther away. Okay, so that is the demo of how it nets up. And now, as I mentioned, I'll go a little bit more into the details. Firstly, I'll go to File, preferences. And we'll see there's a new section here called Python settings. So for these two, you're specifying where Python is in your computer so that Geoscience Analyst can access all those Python modules that are in your script. Then for this add directory to Python path, if I just copy this to my file explorer, you'll see that this is where I have my actual .py, my Python script. So that's that Python script that was running in the background for this distance computation. Now, secondly, here in that Python menu, we have this open scripts directory. This is where we have my UI.json, which I'll just open to show you really quickly. I'll open it with PyCharm, but this is a text file, so you could be opening it in any text editor. Okay, so there's this UI.json file. It describes the commands like a dialog box, and then what script it's going to run and where to find things in general. So you can see here it's indicating the source, which types of objects I can select here in the source menu. Same thing for my destination. And then it's also specifying which Python script it is going to be running. Now, this looks a little bit intimidating, but it shouldn't be all that bad. And if you are interested in creating your own UI.json, then we can go to Geotiff, read the docs. And in there, you should see a section for UI.json. And here there's a description of all the different parameters and all the different things you need to set that up. So this could be a useful reference if you would like to set up your own UI.json. Now, there's also the open working directory, and that's just where it's going to be writing any temporary files to. And then you should have your list of scripts. So this way you don't need to be opening your Jupyter notebook and refreshing Geoscience Analyst all the time and worrying about monitoring directories. You should be able to just access all of your different Python scripts from within Geoscience Analyst. And that's all I have planned for today. I don't know if there's any questions.
That's all? That was amazing. Thanks. I can't wait to get my hands on this release. Thanks, Carla. And thank you for all who joined us today. For those of you who are in the lecture, we'll give you about a half a minute to type any questions that you may have in the Q&A. If you have any questions in the future, please do not hesitate to email us at support@mirageoscience.com. And join us next month when James Reed will demonstrate visualizing and preparing electromagnetic data for inversion with Geoscience Analyst Pro Geophysics. I will warn you that the next lecture will take place during Australia Western Standard Time, since James is in Perth. So if you're in North America and you're not a night owl, don't forget to catch it on the recording on YouTube afterwards.
Okay, so it looks like that's it.
We have one hand up. Let me.
Ooh, do we?
Yes.
Hi there. Can you hear me?
Yes.
Yeah.
Perfect. That was an awesome presentation. I loved it.
No, thank you.
Yeah. So when you wrote the Python script, did you have to go through some parameters that would make your Python script compatible with this particular application, or was it just a plain scripting?
Right. So I can show my Python script here. So I did import the GeoH5Py modules here so that I could like just load data from the workspace and then also write back to a block model or a surface or whatever it may be. So here, yeah, I can create new data on my destination object right here. And maybe Chris, you could explain that a little better. not a Python expert here.
Yeah, so that's right. So you're just using GeoH5Py, and when you want, if you can scroll up a little bit there, Carla, when you want to read it, everything gets put out as a value in the JSON. So that source and destination there under the workspace get entity is basically going into your GeoH5 workspace and grabbing the entity with that unique ID from the source parameter given the value. So that's exactly what we export when we export the UI JSON, is we export the unique ID of that object. But if you wanted an integer or a float or anything like that, we would also have that value. So you would need to know what your parameters would be required for your script. But the idea here is you'd have a script and you could basically write a little front end to it and then just read that front end parameter and get what you need.
Okay, no, that's great. Just a follow up then. I have worked with the previous versions of this software. They were quite a few years ago. You guys used to create a Geosoft module, and I had some really good results getting inverted data imported into Leapfrog. Would the same compatibility be offered with this version of Analyst?
I'm not quite sure I exactly understand the question. We definitely have the exports. So Leapfrog should be able to handle our exports, at least into the ASCII and the other known formats.
Oh, okay. Okay. Yeah. Okay. No, that sounds great.
Okay, and we did have a question about if there's a place where we post useful Python scripts, such as this one. I guess I would say we haven't added that place yet, but we do have the GeoApps repository, which we have started adding UI JSON importers to. Do you have so I think we will get to a place where we will we'll start putting some useful scripts together and adding them in. All right, I think that's all. Thank you for everyone again for all the great questions, and we'll see you next month.
All right, bye everyone. Thank you.